Imagine standing on Earth for 0.5 billion years ago. But this isn't the blood-filled planet we know today. Instead, it's a world of fire and chaos, a molten hellscape where rivers of lava stretch as far as the eye can see. The air is thick with toxic fumes, and meteors rain down from the sky, shaking the ground beneath you. Oceans? They don't exist. Life? Impossible. And yet, somehow, over millions of years, this burning wasteland transformed into a water-covered world. But how? Where did water, Earth's most precious element, come from? The answer might be more incredible than you think. Water, it's the foundation of life as we know it. Every drop tells a story billions of years in the making. But here's the mystery. When Earth first formed, it was a scorching, molten fireball, completely uninhabitable. There were no oceans, no rivers, not even a single drop of water. So where did it come from? Did it rise from deep within the Earth? Or did it arrive from the far reaches of space? Scientists have spent decades unraveling this mystery, proposing theories that range from volcanic steam to icy comets crashing into Earth. Today, we're diving into the most fascinating possibilities to uncover the origins of Earth's water. Because without it, life wouldn't exist, not here, and maybe not anywhere else in the universe. So, buckle up as we journey back in time to discover how our planet, once a fiery wasteland, became the blue world we call home. Formation of early Earth. For 0.5 billion years ago, our solar system was nothing more than a swirling cloud of gas and dust. Then, something incredible happened. Gravity pulled these particles together, forming the sun at the center. But around it, countless smaller pieces collided and merged, slowly giving birth to the planets. One of them was Earth. But this young Earth was nothing like the planet we know today. It was a violent, chaotic world, a scorching sphere of molten rock, constantly bombarded by asteroids and comets. The surface was an ocean of lava, temperatures soared above 2000 C 3600F, and the atmosphere was filled with toxic gases like carbon dioxide, methane, and sulfur. Oxygen? Nowhere to be found. Then came a cataclysmic event, the Theia impact. A Mars-sized protoplanet slammed into early Earth with unimaginable force. This collision didn't just reshape the planet, it also ejected massive amounts of debris into space, which later coalesced to form the Moon. The impact further melted Earth's surface, turning it into a seething ocean of magma. For millions of years, our planet remained a hellish, fire-covered world. But slowly, things started to change. As Earth's core stabilized, it began generating a magnetic field, shielding it from deadly solar radiation. Volcanic eruptions became less frequent, and the planet started cooling very, very slowly. But one mystery remained. If Earth was once nothing but molten rock, where did the first drops of water come from? Was it already hidden deep within the planet? Or did it arrive from the farthest corners of the universe? To find the answer, let's explore the leading scientific theories about the origins of Earth's water. How did water arrive? Water so simple, yet so essential. Today, our planet is covered in it, with oceans making up 71% of Earth's surface. But 4.5 billion years ago, Earth was a waterless wasteland. So how did this life-giving liquid appear? Scientists have explored multiple theories, each offering a fascinating glimpse into the planet's past. Theory 1. Volcanic outgassing water from within. One of the most widely accepted theories suggests that Earth's water came from within the planet itself. When the young Earth was still molten, its interior contained large amounts of hydrogen and oxygen, the two elements needed to form water. As the planet cooled, massive volcanic eruptions dominated the landscape, releasing enormous amounts of water vapor, carbon dioxide, and other gases into the early atmosphere. Over millions of years, this steam condensed into liquid water, forming the first raindrops. But was volcanic activity alone enough to fill entire oceans? While outgassing likely played a significant role, some scientists argue that it couldn't have produced all the water we see today. That brings us to another fascinating theory. Theory 2. Asteroids and comets. Water from space. What if Earth's water didn't originate here at all? Some researchers believe it was delivered from deep space, carried by icy asteroids and comets that bombarded Earth during its early years. During a period known as the Late Heavy Bombardment, around 4.1 to 3.8 billion years ago, countless asteroids and comets smashed into Earth. Many of these celestial bodies were rich in ice and water. Upon impact, they vaporized, releasing their water into Earth's atmosphere, where it eventually condensed and rained down to the surface. Evidence for this theory comes from studying the chemical composition of water on Earth compared to water in asteroids. The isotopic ratio of hydrogen deuterium to hydrogen ratio found in some asteroids closely matches that of Earth's water. This suggests a cosmic connection, perhaps a significant portion of our oceans once drifted through space before crashing down onto our young planet. However, there's a counter-argument. If comets and asteroids delivered all of Earth's water, why don't we see similar water coverage on other rocky planets like Venus and Mars? Scientists believe that while asteroids and comets may have contributed, they weren't the sole source of our planet's vast oceans. Theory 3. Chemical reactions. Water created on Earth. A third possibility suggests that water formed directly on Earth through chemical reactions in the early mantle. The young Earth was rich in minerals that contained hydroxylo groups, which, under high temperatures and pressure, could have released hydrogen and oxygen. These elements then combined to form water deep within the planet. Over time, this water made its way to the surface through volcanic activity, eventually accumulating into oceans. This theory is intriguing because scientists have discovered ancient water locked inside minerals deep within Earth's mantle, suggesting that at least some of our water came from deep underground rather than from space. So, which theory is correct? The answer is probably all of them. Scientists now believe that Earth's water is the result of a combination of volcanic outgassing, asteroid and comet impacts, and chemical processes deep within the planet. Each process contributed over millions of years, transforming Earth from a fireball into a water-rich world. But now that we know where water came from, another mystery remains. How did Earth cool down enough to allow water to exist in liquid form? Let's explore the next stage of our planet's transformation. The cooling of Earth. The birth of oceans with water beginning to accumulate on Earth's surface. Another crucial transformation had to take place. The planet had to cool down enough for liquid water to remain stable. But how did a once molten world, hot enough to melt rock, transform into a cooler, ocean-bearing planet? The long road to cooling. For millions of years, Earth remained a fiery wasteland, radiating intense heat into space. But slowly, a series of events began to change its fate. 1. The thick atmosphere traps heat. Early Earth's atmosphere, filled with carbon dioxide, methane, and steam, acted like an insulating blanket, trapping heat from the sun and slowing the cooling process. Unlike today's sky, early Earth skies would have been dark, thick with volcanic gases, and completely clouded over. 2. Volcanic eruptions release steam. Volcanic activity played a crucial role in forming the early atmosphere, constantly spewing out water vapor, sulfur dioxide, and carbon dioxide. Over time, the steam started condensing into clouds, a sign that Earth's surface was cooling. 3. First rainfall. A planet-wide storm. As the upper atmosphere cooled, rain finally began to fall, but not just any rain. This was a planetary-scale downpour that could have lasted for thousands, if not millions, of years. Imagine torrential, unending storms, with raindrops sizzling as they hit the still hot ground, evaporating instantly. But as temperatures gradually dropped, the water stayed, collecting in low-lying areas to form the first bodies of liquid water. 4. The formation of the first oceans. Over millions of years, rainfall continued, slowly filling the planet's depressions and basins. These collected pools merged into massive oceans, covering vast portions of Earth's surface. Earth had now transitioned from a molten wasteland to a water-covered planet. The Great Cooling Debate. Scientists debate how long this process took. Some suggest Earth cooled relatively quickly, within 10 to 20 million years, while others believe it took hundreds of millions of years before the planet was cool enough to sustain stable oceans. One thing is certain: Earth's cooling wasn't a smooth process. Volcanic eruptions, asteroid impacts, and fluctuating temperatures continued for millions of years. But despite the chaos, water remained an essential ingredient that would eventually give rise to something even more astonishing: life. But how did the presence of water set the stage for life's first appearance? Let's explore the next chapter in Earth's incredible journey. The first drops of water, a turning point for life. With Earth's surface finally cooling and vast oceans covering the planet, something extraordinary was about to happen. Water was more than just a passive element, it became the catalyst for life itself. But how? Water, the ultimate chemical laboratory. Water isn't just a life-sustaining liquid, it's a powerful solvent that enables chemical reactions. Scientists believe the first oceans acted as nature's laboratory, allowing elements and compounds to mix, collide, and transform in ways never before possible. Organic molecules begin to form. Early oceans were rich in minerals, carbon, and simple compounds. A lightning, volcanic activity, and even asteroid impacts provided the energy needed for chemical reactions. Slowly, complex organic molecules like amino acids and nucleotides, the building blocks of life, began to appear. The primordial soup theory. Many scientists believe that Earth's early oceans function like a giant primordial soup, where organic molecules combined and evolved over time. These molecules eventually formed self-replicating structures, leading to the first simple forms of life. Water's role in protecting life. Water also provided protection. Unlike the barren, radiation-exposed surfaces of other planets, Earth's vast oceans shielded early molecules from the sun's deadly radiation. Beneath the surface, the first microscopic organisms had a safe environment to evolve. One of the most fascinating theories suggests that deep-sea hydrothermal vents, cracks in the ocean floor spewing mineral-rich, warm water, could have been the birthplace of life. These vents provided heat, energy, and nutrients, creating the perfect conditions for the first life forms to emerge. But life didn't appear overnight. It took millions of years of trial and error, with molecules constantly forming, breaking apart, and recombining. And then, one day, the first simple microbes were born, a moment that would change Earth forever. With the planet transformed from a fiery wasteland into a world filled with water, the stage was set for the next great chapter in Earth's history: the rise of life. But how did simple molecules evolve into complex organisms? Let's uncover the next step in this incredible journey: the rise of life. From molecules to microbes. With Earth now covered in vast oceans, the conditions were finally right for something truly remarkable: the emergence of life. But how did simple molecules turn into living organisms? This is one of the greatest mysteries of science, and while we don't have all the answers, researchers have uncovered fascinating clues about how life may have begun. The perfect ingredients for life. Life didn't appear suddenly. It was a long, gradual process that took hundreds of millions of years. Scientists believe it all started with the few key ingredients. 1. Water. The medium where chemical reactions could occur. 2. Carbon-based molecules essential for forming life's building blocks. 3. Energy sources. Lightning, volcanic heat, and even deep-sea vents provided energy for chemical reactions. 4. Time. Millions of years of random interactions led to the first self-replicating molecules. But where exactly did life start? Scientists have proposed several possible locations. 1. The deep-sea hydrothermal vent theory. One of the strongest theories suggests that life began near hydrothermal vents on the ocean floor. These vents released superheated, mineral-rich water, creating a stable environment with the energy needed for complex chemical reactions. Microbes today still thrive in these extreme environments, supporting the idea that life may have first emerged in the deep ocean, away from harsh surface conditions. These vents produced compounds like hydrogen sulfide and iron, which helped fuel early biological processes. 2. The primordial soup theory. Another theory suggests that life originated in shallow pools or warm ponds, where the concentration of organic molecules was high. When lightning or ultraviolet radiation struck these waters, it triggered chemical reactions that led to the formation of simple organic compounds. Over millions of years, these compounds linked together, forming amino acids, proteins, and eventually self-replicating molecules. Famous experiments, like the Miller-Urey experiment 1953, demonstrated that when electrical sparks simulating lightning passed through a mixture of gases similar to early Earth's atmosphere, they produced amino acids, the fundamental building blocks of life. 3. The panspermia hypothesis. Could life have come from outer space? The panspermia hypothesis suggests that life's building blocks arrived on Earth via comets, asteroids, or meteorites. Scientists have found organic molecules on meteorites, including amino acids and sugars, suggesting that these life-forming compounds existed in space before reaching Earth. If true, this means that life didn't necessarily start on Earth, but was seeded from elsewhere in the cosmos. While we don't yet know which of these theories is correct, one thing is clear: the combination of water, chemistry, and time created the perfect conditions for life to arise. The first life forms, microbes, take over around 3.8 to 4 billion years ago. The first living organisms appeared single-celled microbes. These were the ancestors of all life on Earth. These microbes were anaerobic, meaning they didn't need oxygen to survive since early Earth had very little oxygen in its atmosphere. They relied on simple chemical processes, like consuming minerals and breaking down molecules for energy. One of the most important evolutionary breakthroughs came with the rise of cyanobacteria, tiny microbes that could perform photosynthesis. These bacteria absorbed sunlight and used it to produce oxygen as a byproduct. Over millions of years, their activity gradually filled Earth's atmosphere with oxygen, changing the planet forever. This event, known as the Great Oxygenation Event (GO), paved the way for more complex life forms to evolve. What started as a barren, fiery world had now become a planet filled with water and primitive life. But this was just the beginning. Life would soon evolve into more complex organisms, eventually leading to plants, animals, and even humans. A fiery beginning to a blue planet. Looking back, it's incredible to think that our planet, once a scorching fireball, transformed into the water-covered world we see today. Earth started as a molten wasteland, bombarded by asteroids and comets. Over time, water accumulated through volcanic outgassing, asteroid impacts, and deep Earth chemical reactions. This water cooled the planet, forming the first oceans, which became the cradle of life. From simple molecules to the first microbes, life slowly took root, eventually leading to the complex world we know today. And all of this was made possible by one simple ingredient: water. So, the next time you drink a glass of water, take a moment to appreciate its incredible journey. That drop of water has been part of Earth's story for billions of years, carrying the legacy of our planet's fiery past. And who knows, maybe the story of water and life has already begun on other planets across the universe. What if Earth's history had played out differently? If water had never arrived, what would our planet look like today? Would life have ever formed? Or would Earth be a dry, lifeless rock drifting through space? That's a question for another time. But one thing is certain: without water, we wouldn't be here today. If you enjoyed this story, make sure to like this video, it really helps us out. Share it with friends who'd love to learn something new, and subscribe to the channel for more fascinating content like this. Don't forget to turn on notifications so you never miss an update. Thanks for watching, and I'll see you in the next one.